All right, folks, here we go. Michael Aubrey McKenzie, I think this is who is for. We are on 3-6. There are only 4 homework problems for 3-6. That's exciting. This is the last section of the chapter. We'll finish notes today. Tomorrow I'm going to be gone, and Wednesday I'm going to be gone. I am leaving a review for you guys to do. Yeah. Do you guys want a video with review?
Yes.
How do you want me to format it? Do you want me to say first 10 minutes of class do problems or attempt problems 1 through 10 and then start watching the video and then I'll give you all the answers? How do you want to do that?
You
I like when you just work them together.
Just work them together?
And then people can go ahead and come back.
Go ahead and come back. Pause the video as you work them maybe. Because some of them, you should be able to do most of them on your own. Or try them anyway. I don't know. Okay, we'll cross that bridge when we come to it. Here we go. Let's skip example 4 because example 5 is similar to that. Let's roll. Here we go. Carbon 14 has a half-life. Have you guys talked about half-life in physics or science class or whatever? Okay. We have talked about it in here probably. Okay. Half-life. Carbon 14. A lot of like prehistoric animals that are dead, they test their bones for carbon 14 and they figure out what the content of carbon 14 is. And then they can use that to determine how long the animal has been deceased, okay? So let's say we have an animal that has 100 grams of carbon 14. I have no idea. Carbon 14's half-life is 5,730 years. That means that's how long it takes for it to cut in half. So 5,730 years have elapsed. How many grams of carbon 14 are left? 50. And then another 5,730. How much is left? 25. And then another 5,730. How much is left?
Still not a lot.
12 and a half. And another 5,730. That's like 20,000 plus years. That is 6.25. And it keeps cutting in half and cutting in half and cutting in half and cutting in half. And we can figure out by the end, like how many years-ish have elapsed. And that's how they date these prehistoric animals that they find the bones of. What do you need?
How long do you think will be my teaching?
Who do you need?
Nobody.
Okay. Come back in 15 minutes.
What are you?
Okay.
This is commentary.
All right. So half-life. This is the equation that they give us for half-life, yeah? Okay. They say write me an equation that takes particularly carbon 14 into consideration. And here we go.
You know it's 5,730.
5730. Which variable is that in here?
Probably time.
Nope.
K.
It's actually K. K is what they use for half-life. A lot of times I use H. So 5730 goes in here, yeah? Okay? Now, here's the deal. They don't give us an initial value and they don't give us an ending value. So like kind of ish we get to pick. Okay? How many grams of carbon 14 do you want to start with?
53. One.
Pick a nice number.
1 gram. 507.
Let's pick 100. Because I'll show you here in a second. It doesn't matter what you pick to begin with. After 5730 years, what will Q of T be? What will the after amount be?
50.
50. Yeah? 50 years. That's my output amount after 1 year of this stuff going on, right? Okay? So the deal here is if I have 50 equals 100 e to the negative 5730. The only number I don't have plugged in for is t, yeah? What we can do is, the first thing I would do is divide by 100, right? So this would be 0.5 is equal to e to the negative 5730t. And I can plug in for t and figure out what I want. Well, actually, t in this case should be 1. It should take 1 year for it to turn into 0.5, right? But they're just saying write an equation for it. So we've written an equation for it. T years, if no additional carbon 14 is ingested, t years later, my equation should look something like that, right? Okay? Now, what they've done is take a look at this equation down here. Okay? The difference between these two is that my 0.5 is on the right side of the equal sign, okay? But they've left the P and the A up for me to add different numbers in for P and A. So let's say I don't want to start with 100 and I don't want to start with 50 or whatever. I can now plug different numbers in for P and A, but take a look at this T over H. Now that the 1/2 is on the right side instead of on the left, it's not negative H, or what did they call it? They called it K times T. Negative K times T, they've written it as T over H, or T over K, right? Okay? Like a negative exponent flips it down to the bottom. True? Like negative KT, the negative K is now down in the bottom in the denominator of the exponent, yeah? You see how that works? Okay? So this is now my formula for half-life. They were just trying us to get to that point on our own, which is kind of what we've developed in part A. They want us to find, on part B, an archaeologist uncovers human remains at an ancient Roman burial site and finds that 76.6% of the carbon-14 still remains in the bone. How old is the bone? Okay, now real quick, let's guesstimate. 76.6%. It has not yet split in half, true?
Correct.
So it takes 5,730 years in order for it to split in half, yeah?
4.
So I'm going to guess that it is less than 5,730 years, right? Probably maybe 3,000 years or 2,000 years or something like that, because I still have 76% remaining, yeah? Okay, let's use, I like this equation better. Let's use this equation to figure out how old the bone is. When it says how old, what are we solving for?
Time.
Time. Okay, we don't know time. That's the question mark. Okay, so A equals P times 1/2 to the T over K power, or H power. If you want to use T or H, it doesn't matter. Okay, what?
Where did the E go?
The E? Oh.
I know, but these are not full.
Oh yeah, the E is gone.
1/2 can just be plugged in for E. Well, we outlined.
Yeah. Oh yeah. Yeah. I don't know. Okay. This equation with the E in there and this one somehow are equivalent to each other. Like, I guess when Josie says if you ln and get rid of the E and do all of those things, evidently this guy with the E involved is the same as this guy without the E involved. I don't know. I like to use this equation. Okay, so T over K power, we're running to the nearest 100 years. Okay, so I know that K is 5730. Yeah, I'm trying to solve for T. What is P and A?
100.
Okay, let's start with 100. If I start with 100, how many grams are left over at the end? 76.6 grams, right? So I've got, let me write this cleaner, 76.6 equals 100 times 1/2 to the T over 5730. Can I multiply the 100 and the 1/2 together?
No.
How's come?
You just can't.
1/2 is to this power, 100 is not. So I can't just combine those two together. Okay, so what would you do first?
Take
Bye-bye.
any number you want, like 100.
Yeah, so
You might as well just pick one.
you might as well just pick one because then you don't have to divide by anything, right? Okay, we just need whatever this guy is and this guy to be in the relationship of 76.6%.
So why don't we just...
So you could have just put 0.766 equals 1. Really, you don't even need the 1. 1/2 to the T over 5730, right?
Why'd you put point? Okay, let's change it now, right?
Because that's what it is divided by 100. Does that make sense?
How'd you get
This is 76.6% as a decimal.
Where'd you keep the 100?
We made that up. Like if we start, okay, so it says that 76.6 of the carbon-14 still remains, right? That's what's left over afterward. So if I were to start with 100, that means 76.6 would be left over. Yeah? If I started with 1, it would be 0.766 left over. Do you see how those are in the relationship of that? 0.766 is what's left over. You kind of like get to choose what your principle is, but you just need to make sure that your after amount is 76% of that, yeah? Maybe ish. I don't know. I just always do 100 and whatever the decimal is that they give me. Or you can just start at this point where your decimal is there already and you don't have a number to divide by. Okay. Okay, now what? What shall we do now?
You can't do anything.
You
Now
can't do
let's
anything.
change to log.
Now let's change to log. Do you want log or ln?
Log.
Log. So let's log both sides. Log, log. Okay, and then what?
Move the whatever to the front.
Move the whatever to the front. Okay, so we've got log of 0.766 equals t over 5730 times log of 1/2. Or I'm going to say log of 0.5. Okay, now what would you like to do?
I missed a whole lot. Hang on, hold on. Hold on. Can we zoom
Like the
out a
t to
little
this t over 5730 came down to the front.
bit? We have to log both sides though?
Yes, we logged both sides and the t over 5730 came down to the front. Now what?
Can you multiply by 7 whatever now?
You can. I'm going to
Subtract the
divide.
logs?
I'm going to, he's multiplied, so we've got to divide. I'm going to divide by log 0.5.
Wait, I have a question.
Yes, dear.
I changed 0.766 equals 1/2 t to the whatever. I changed that to log. Can I do that? I just like changed it to a log.
Oh, sure. You did log base 1/2 of 0.766. Sure, that would work. Yeah. Because log base 0.5 of 0.766, if I want to get it in base 10 form, I do this to it. Yeah, so that works. Okay, but if you want to put it in as log base 0.5, that's fine.
So it's
Okay.
0.385.
That's what this is, 0.3? 0.385 equals t over 5730.
Now.
Now times 5730.
2203.
2203.
Yeah.
Okay.
2200 if they want it.
Oh yeah, nearest 100 years, so 2200 years about is what t is. Is that what we guesstimated?
Yep.
We said it couldn't be 5730 years because it hasn't yet split in half, right? So kind of do some of that guesstimating beforehand just so that when you get an answer at the end, you're like, is that even right? Yeah, that's right, 2200 years. Okay?
Yeah, I just changed it to log and then divided or multiplied by 5730.
Yeah, that's fine.
Okay.
Yeah, that's fine. That works just the same. Okay?
No.
All right, so more solving for logs. This is all you're doing. It's just solving for logs.
Hold on.
They just give you an equation to plop stuff into. That's for half-life. Okay?
2, 0. What's logistic growth?
Logistic growth. Hold on. I'll wait for yours.
Okay, you're good.
Okay, logistic growth. This is the last main concept that they have. We haven't talked about logistic growth, I think, in any other math class besides trig. So listen up. Put your listening ears on. Logistic growth. This is what a function that has logistic growth looks like. Okay? Logistic growth is kind of like a little adaptation from exponential growth, okay? So I told you before that like an exponential function crosses 1 and he goes up like this forever and ever and ever and he goes like that, right? Okay? Now, if I were trying to relate this to like a story problem, let's say like population, right? We started with bacteria on a piece of bread, right? Okay? So we start with a really low amount of bacteria on a piece of bread, and then they multiply and multiply and multiply and multiply and multiply, and then they like increase like really rapidly. Like as soon as you get like one mold spore on a piece of bread, it's like disaster. There's mold everywhere. True? Mm-hmm. Bacteria spreads super fast, okay? So we've got this going on, except is the mold going to continue to grow forever on that piece of bread? Like what's going to happen? It's going to what? It's going to level out somewhere like this. Why does it level out? There's no more bread for the mold to eat, right? Like it's going to run out of its food source. True? So it like levels off like that. And what happens with that is it has like a horizontal asymptote up here in the air of where it's going to level off at, like determined by the weight of the bread or whatever it is that it's going to level off at. Does that make sense? Okay? And that is a logistic function. So a logistic function is like a more realistic exponential function because it takes into consideration that eventually it will level off. It's like population of people in a city, right? It might grow exponentially, but is it going to grow forever? Will people continue to populate the earth forever and ever and ever and grow, 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 grow? What's going to happen to us? We have people dying all the time as well, but like our population in general is increasing. We're going to run out of space. We're going to run out of food to feed these people, right? Like it's just not going to continue to grow forever. So that's what a logistic growth model is. Now, C, circle C on the top. This is where your HA is going to be located. Okay, your C here, your C is going to be your upper limit, like what his cap is, okay? Where he's going to level off, that's what where your HA is positioned up in the air, okay? What?
Like, is C going to be in scientific notation since it's so big or not?
Not you. It doesn't have to be big.
No.
Sometimes, well, okay, I shouldn't say that. A lot of times, like your equation is like in millions, so they'll have like 103 is your upper limit, but that's in millions. So it's kind of like scientific notation. It doesn't have to be like a super huge number though, either. Whatever. Okay, let's see an example. So here we go. This is 93.3. That's my upper limit, and we are in millions. We're talking about the population of California. That's my upper limit. 93.3 million people is evidently the upper limit of California. That's what we're going to level off at, okay? So it says where T is the number of years since 2010. 2010 is my 0, right? Not 2000, 2010, okay? Determine the population in the year 2010. What is the population in the year 2010? So what do I plug in?
20, 10, 10.
No?
No 10.
What do I plug in for T? 0. I plug 0 in. Okay, let's do some of this in our head. Ready?
Wait, how do we know?
Hold on.
Because
Hold on.
Because 2010 is the
2010 is my starting year. So T is the number of years since 2010. So if I want to know 2010, that's 0 years since 2010. What's 0 times negative 0.013? 0. What's e to the 0 power? 1. What's 1 times 1.5? 1.5. What's 1 plus 1.5? 2.5. So 93.3 divided by 2.5 is the number that I want, and that is something.
37.32.
37.32. That is in million. Okay, so that is my population right now in 2010 of California. 37 right now in 27. That's my initial. That's like my P number, right? Okay, 37.32 million. Use this function to determine the time required for the population of California to double from this value. Okay, I want it to double. And let's see, and compare this with the result from examples 3C. Okay, so here's my function. I don't have my initial in there.
But can we set it equal to 74.6?
Yeah, what would the after amount be?
74.6.
74.64, you said?
Right? 32 plus 32.
Yep, sure. 93.3 over 1 plus 1.5 e to that junk. Negative 0.013 t. Hold on, I'm moving him. There we go. Okay. There's my formula. I just plugged in this number, 74,000 or 74 million, I guess, whatever. Okay.
Switch them.
Now we've got to figure out how to do this. We're solving for t. T is down here in the bottom. We got to do a lot of algebra stuff. Yeah. Okay. Reese said we switch these two. Did you know that you could do that? Yeah.
Does it all the time.
Yeah, Muth does it all the time with like the triangular method, you know what I'm talking about? Okay, so 1 plus, can I add this 1 and 1.5 together, by the way?
No.
No, the e is trapped with the 1.5, so we can't do that, okay? Equals 93.3 over 74.64, okay? Do you see what I did with switching those two?
Yeah.
Okay, now let's do some stuff. What is 93.3 divided by 74.64? 1 point something.
2.5.
1.25? Awesome. Okay, now what? We can do some more algebra.
Minus the 1.
Minus 1. Minus 1. So I have 1.5 e to that junk
So it's 0.25 now.
equals 0.25. Okay, now what?
1.5
Can I have
is e to the.
Can we log Elena?
Nope, not yet. Just wait.
T is equal.
One more.
You have to divide by 0.5.
Divide by 1.5. Yeah?
So 0.167.
E to the negative 0.013 t equals point what? 67?
Yeah. No, 1. Put a 1.
1.67? No. 0.167. Got it. Got it.
Ellen.
Okay.
Ellen.
All right, I'm zooming out here. Okay, Ellen?
Slow down.
0.0.
Okay, I'll pause for a second.
I got
Okay, ln both sides. Negative 0.013t equals, what's ln of 1 or 0.167? What is that number?
Negative. Wait, should I have a negative number?
Yeah.
1.79.
Negative 1.79 was ln of this, right? That's a negative 1.79. Now what?
Divided by negative 0.0.
Divide by negative 0.013.
167.7.
167.7. Okay, that's not the right answer though. 167.7 is my years. And that is years past what?
2010.
2010. So if I add 2010 to that, this is the year 2177.7. So almost the year 2178. Ugh. Okay, that's when my population of California is going to be double what it is now.
Awful.
Okay? What is
So
the
what-
limiting value of the population under this model?
How do you 21 point what? How do you know when you've like hit the max?
What do you mean?
Like cap.
How'd you guys get 167? I got 137.
That's what I got too.
You got 137?
Yeah, that's what I got too.
Maybe I just wrote it down wrong. Sorry. 137. Good call. Good call. So this should be 2147, yeah? I'll write that down.
T is equal
2147.7.
I for sure probably said it wrong, but I for sure have 137 on here.
Oh, really? On your calculator, yeah.
Yeah.
2147. That's what I get for that year. Okay? Hold on. I'll answer your question here in a second. C, what is the limiting value of the population? What's the max that the population can be for part C? 93.3 million. Now, it doesn't matter if we are in the year 2500, right? We could be in the year 2500, which is a long time from now. We will not have gotten to 93.3 million yet. It'll be like 93.2 million,
So wait,
right? It'll be right there underneath.
is the
But it
time
will
for
never
C
reach
or is the
93.3 million.
year?
Exactly. Does that make sense? What?
Is the year like is the time 2,500 for C or is 93.3 million for C? What's the-
93.3 million is for C. Part B was the 2147.
The 25.
The 2500 means nothing. I just made that up. Okay? 2147 is part B. C is 93 million. That's my upper cap. Okay? So, when you guys were asking me, like, at what point will you reach that upper cap? You won't. Because your function, your exponential function, is going to do this and then it's going to level off. So, this upper limit is 93.3 million. You could be in the year 2500. You could be in the year 3000 and you will not have reached 93.3 million because we cannot, like, accommodate that many people. We don't have enough room. We don't have enough food for all of those people. We will never reach that 93.3. We might get to 93.2, but we'll never actually reach that top amount. Does that make sense? Okay? So that's how a logistic function works. Okay? You solve it just like you would do an exponential function, except you have to like flip the bottoms. Okay? But otherwise. All right? Ready? Okay, this is where the hard part comes in. Are you ready?
No.
Maybe hard part. Graph the data. Okay, here we go. If you have your graphing calculator, you need your graphing calculator, your big fat one. Yeah?
Oopsies.
Okay, you need your big fat graphing calculator. Look onto somebody's Tate if you don't have one. Okay, look onto somebody's. We are going to graph this data.
We're out.
Okay, so here we go. Your steps, if you're following along on the computer, here's how this works, okay? What you need to do is you need to program this into your calculator. So first thing I want you to do is go to second y equals is that button, and turn your stat plots on. Where it says stat plot 1, turn it on. Okay?
Hold
You
on.
hit second y equals and you turn your stat plot on so that we can plot data points.
It's already on.
If it's already on, great.
What if 5's on too?
Okay. Yeah, I don't care. We don't have anything in 5. We just need the first stat plot on. Okay? So that it'll plot points. Anybody not understand what I'm doing? Turn your stat plot on. Eli, turn your stat plot on. Second, y equals. Turn stat plot on.
How do you turn it on?
You hit enter and it will take you to a new screen and then you flip it to the on switch.
Okay.
Questions about that? Do you know what we're doing? Okay. Second step is you go to the stat button. You see where it says stat? It's a button. And then you go to, is it down to edit? No, it's already on edit. Okay, stat edit. So you might just have to hit enter.
Hold on.
Okay, stat edit. It's already on edit. If you hit the stat button, so you just hit enter. And you get to your list 1 and list 2. Okay, you want to clear out your list 1 and list 2, but after you clear them out, you want list 1 to be these 1, 3, 5, 7, 9, 11, and you want list 2 to be 300, 161, 89, 50, 27, 15. All those good things. Okay? All right? List 1, list 2. Anybody struggling? If you're trying to clear it out, you can go to the top, like hover over L1 and hit clear, enter, and it will clear out your whole list. Okay? Anybody struggling? Stat?
Actually, like a calculator nerd.
Yeah, I did that.
Okay, now you want to go to this list right here. 1, 3, 5, 7, 9, 11.
Okay.
Okay, go over and enter the other one. Okay, we're gonna say calculator, make me an equation. Go.
Is this what it's supposed to do?
11.1, 11.1.
Okay, that's right. We're gonna change the window.
You spoke to me.
Did you guys graph them yet? Or you got them in there? L1, L2, you're putting those in your list?
No.
Got it? We're gonna graph that. If you hit graph, it might show something funky weird. Because we need to change the window. Change window.
Let's put it to like 5 by 3.
Come on.
Okay, now let's choose what we want to put our window at. You have a min and a max number for X. So X min, X max, Y min,
Is this on the homework?
Y max, yes. I think.
I skipped this one.
X min, X max, Y min, Y max. Okay, what's your lowest X?
3.
Or a one.
1, let's put 0. Okay, what do you want your X max to be?
You're just saying random. You're just saying random numbers back there.
12.
12. Let's put him as 12. The minimum Y.
The scalar, do we need anything for the
No, you can just leave him as 1. It doesn't matter. It's just like what your units are going by. Y min, what do you want your smallest Y to be? 0?
10.
Should we go 0? You can go 10. It doesn't matter. 300 is the biggest. Let's go like 320. I don't know. 0 and 320. Okay. Now hit graph. Okay. All right. What does your stat plot look like if you hit graph?
Error.
Error.
He looks like this. I don't have a line
Let's
down.
see him. Oh, he looks nice. He goes like this.
Do we need to draw
Here and here and here and here and here and here. That's what he looks like, ish. Are you getting him to look like that? You don't have to graph this. He's already on your thing. I'm just showing the people who are watching this on a video. Your window should look like that if you graph it. Yeah?
You need some
Okay, let's decide. Part B.
Yeah, there you go. There you go.
Part B says, from visual inspection of the graph, which model would best represent this? Is it a linear function? Is it exponential or logarithmic?
Can you show rhythmic?
Okay, exponent or linear is a line. Exponential is either, let's put them right here. So linear.
Looks like exponential.
Linear is like this. Exponential is either like this or like this. Okay, log. Okay, exponential has a horizontal asymptote and a horizontal asymptote. Log looks like this, where he has a vertical asymptote. Okay, or the other way. Okay, or the other way, where he's looking like, I gotta think, like this. That's log. Okay, so is this, which one of these 3 is it?
Hold on for 1 second.
Exponential.
Exponential. I'm gonna guess it's exponential. Okay? If you want to put those little graphs on there, that's great. Last thing. We want the calculator to make me an exponential equation go. So last thing, after we change our window and graph him and make our decision, we go to stat. So hit these buttons again. Go to stat. Go over to calc. Like on the top. Go stat, calc, and then go down to, which regression did we want? Linear, exponential, log. Which one?
Exponential.
Exponential. So go down to EXPREG, and it will spit out an exponential function for you. Okay, and it'll give you like what A is and what B is and all that stuff.
X list and Y list. Don't matter.
Yes. Oh. If it takes you to another screen and it says, what's your X list? Your X's should come from list 1, L1. Your Y's should come from list 2. It should already be on that.
Yeah.
Okay? But if it's not, you can change it. Okay? So go down, hit enter. Enter, enter, enter. You should get to a screen where it says Y equals A times B to the X power, yeah? Okay, what is A?
399.71.
399.71 times, I'm going to put B in parentheses. What's B?
0.7418.
7418 to the X power. Is this growing or decaying? Decaying, right? On the graph it has a decay and that number is smaller than 1, so that's what my decay function is. So I could figure out in, like they plugged in 1, 3, 5, 7, 9, 11, we could plug in 20 if we wanted to and figure out what Y would be. Got it? This was our exponential function. Good?
Yeah.
Okay, let's go to 8. Number 8, example 8 is the same thing,
We don't want to do it.
but let's figure out which one it is. Okay, we have linear, exponential, log. So go to, do you remember what your buttons were?
Second, Y equals.
Go to stat. Well, if as soon as you turn your stat plots on, you don't have to do it again. So all you need to do is go stat edit.
This looks exponential just looking at the numbers.
Stat edit. Do you think so? An exponential growth? Yeah, it could be.
Oh, 7.
Okay, stat edit. Type in your numbers. This is list 1 and list 2. Type in those numbers and see what you get. And then we need to decide, is he linear, exponential, or log? I don't know. It could be log. I don't know. It depends on if he's doing this or if he's doing this.
Oh, that's what that means.
Right? Like concave up.
Oh, so
Oh,
like-
he's
He's
going up.
Oh, that's a log. That's a log. So
Just flick the Y
this
and
is
X
what Ellie's looks like. Like this and like this and like this and like this and like this, something like that, right? Okay. So that's not what yours looks like.
You gotta change
Oh, to change your window. Your X's are going from 1 to 400. So let's go like from 0 to 450 on the X's. The Y's, let's go 0 to 100 for Y, right? Okay. So X's go 0 to 450, Y's go from 0 to like 100, something like that. And you should get a graph that looks something-ish like this. Okay? Now, is that an exponential function? I don't think so. It does have a curve to it. It's like concave downward, right? That's a log function. Okay, really quick. Everybody listen to this. When you're doing log regression, okay, go to stat, stat calc. I want to show you something because everybody gets it wrong every single time. Stat calc. You have two options.
Logistic.
You have logistic reg, and then you have ln reg. Which one is log? Is it logistic or is it ln? Logistic is logistic. Logistic is, there's logistic, exponential, logarithmic. Logarithmic and logistic are not the same.
So it's ln.
Logistic was this one that's exponential and then like levels off. That's what logistic is. You want to use ln reg, not logistic reg. Does that make sense?
What are you talking about?
Okay.
Is this calculator stuff?
Yeah, this is calculator stuff. So, are you on hers? No, you're on your.
All three of ours don't.
Oh, oh, heavens.
I did.
Y equals 3.3.
How much yours?
She's funny.
I knew that answer.
I know. I'll get back to it. Okay, so when you go stat calc, your options, you go all the way down. And you have linear. No. You have ln reg, you have exponential, and you have logistic. We want ln for
Reese,
all,
do you like
not
this
logistic.
one? Which
Exactly.
is not that. None of these are all like
ln.
this one, this one,
Okay, there you go.
or this.
Okay, so you have Your equation should pop up with y equals like a times b ln x. Is that true or no?
Yeah.
Okay, what's a?
Links.
2-2.
3 point what?
3-3.
Mine's 2-2.
3.33
This one gets no.
times.
Mine's 2-2.
Mine's plus.
Mine's plus as well.
Oh, is it plus? Oh, plus. Plus, what's b?
14.93.
14.93 ln x.
You like this one?
You just didn't write a number down, right, Ellie?
No. This one.
There's your function.
I have 2-2
I have to
on
like
here.
put all my stuff in here.
Okay,
You like this one better?
good.
Yeah, like you didn't put a number on your calculator.
I know. But however, all the rest of my numbers are.
Finish designing this.
Well, unfortunately, Josie, you
I
can't
don't
use that
know.
one.
Can't use this girly one.
Because that's the one I'm using.
You have pink and everything.
No, it's blue. It's blue.
It's blue. Are you colorblind? That looks pink to me.
No, mine's blue.
When I wrote down
46782.
Oh
So the 72, 82, 89, 90. Yep, that's it. Changing it one little thing.
Stupid number.
I don't know. Okay, good. Happy with that?
Can you scroll up just a little bit? Hang on.
Yes, yeah.
Can we do number 18?
From yesterday.
Yeah. Let me stop the video here.
Okay.
Okay, done? Good? All right, there we go.